All right. Well, good morning, everybody. My name is Mike Fritzy. I'm the Vice President at the Potomac Institute for Policy Studies. I'd like to thank everyone for joining us today for the second event in our Microelectronics Future Series. This one is called State of the Practice, Keeping Shape. And I'd like to remind everybody to please submit all of their questions to the question Q&A feature in the webinar. Don't use the chat, use the Q&A feature. And I'd also like to remind everybody that this event is being recorded for publication and distribution by PIPS. We're doing this as part of our educational series on a topic of extreme policy interest these days, which I don't have to emphasize to people how important this is today. I'd like to first introduce all of our panelists briefly before letting them make some opening remarks. We're very, very happy to have the industry leaders here, especially very strongly involved with the state of the practice semiconductor technologies. I'm tickled that these folks took time out of their day to do this. It's very important. They're all very busy people, I know. So I'll just go through and let people know who's on this list in case folks haven't read the note about it. We have Mr. Jim Will, who's the business director at Skywater, the Aerospace and Defense Business Director at Skywater Technology Foundry. We have Mr. Ezra Hall, a Senior Director at Aerospace and Defense Business Line at Global Foundries. We have Mr. John Costello, the Corporate Vice President for Government Affairs at Microchip Technology. And finally, Mr. Robert McClellan, a Principal Solutions Architect at Micron Technology. So again, thank you, gentlemen, for joining us today and taking time out of your busy schedule. And I'd like to give each of the panelists a few moments to make a few opening remarks before we go to the moderated format, which is going to be the template that we use for this discussion. So we'll start with Jim Will, if you have any opening remarks. Jim.
Great. Thank you, Mike. Thank you for the introduction. And it's an honor to be in this forum and with the gentlemen on the call today and with all of you. I appreciate the opportunity. So in my career in microelectronics, you know, I've lived this thread, this storybook, chased foundries, moved around the country with my family. In fact, one of the foundries I've been associated with are closed, except for the one here I'm sitting at today in Bloomington. And then moved into the commercial, and so moved into the national security world as a contractor for the NNSA. Really learned mission focus and maintaining our technological superiority, and got a great view of the defense industrial base onshore. So state of practice microelectronics, you know, they supply or consume, they're a major supply to our systems today, and they will continue to be. There'll be additional capabilities that might be integrated with them for additional ConOp or capabilities that other technologies may play, or even state of practice would support. You know, the onshore capabilities or supply, you know, it's in decent shape. There are a good cluster of foundries onshore with their certain capabilities for state of practice, up to state of art if you want to consider RF or different types of applications. But the risks and stability, you know, with viability remain. You have to have a viable business in order to stay around. So I'm excited and I appreciate the efforts of the government recently. This is really probably the most significant groundswelling support for the semiconductor industry in my career, and I started in 1991. You know, and my final comments are that, you know, the industry is the backbone. It enables our economy, drives new technology. It also enables our U.S. defense and maintains our technological superiority.
Thank you very much, Jim, for sharing some of your opening thoughts with us. We'll hear a lot more. I'd like to move on to Mr. Ezra Hall from Global Foundries. Ezra, the baton is yours for any opening remarks.
Thanks, Mike. Good morning, everyone. Very pleased to be meeting with you today virtually. I've been in this industry now for 30 years, the last 16 of which partnering with the U.S. government as a key supplier for secure and assured supply of microelectronics to our warfighters. And I've also had very diverse set of experiences and background in working with commercial customers, and I get to see quite a few analogies between the market sets. And company Global Foundries that I work for now, I've been here for 6 years. Prior to that, 20 years at IBM Microelectronics. we are one of the premier suppliers to the DoD, and I've seen how the customer demands, the customer needs have really led to the right selection of technologies to meet the mission critical applications that the warfighter needs. And it's not all about bleeding edge lithography. In fact, GlobalFoundries went through a pivot a couple of years ago to move away from the very costly leading edge node development and focus on the 90% of the supply that the world needs on feature-rich, pervasive technologies, and that has been incredibly successful for my company. And we have a fab footprint globally, and all of those fabs are 100% full, running at full capacity. Right, it's been a very successful model. And when I look at the defense sector, and I look at the program needs, right, the technologies that are needed to have asymmetrical advantage, right, for this nation and our warfighters. It's about meeting the mission requirements. It's not about the latest buzzword or 5 nanometer or 7 nanometer. It's about the right technology for right applications, and that really takes a complement of all of those technologies, right? Everything from the bleeding edge for certain very narrow but critical applications that need that processing, to the more broad and pervasive uses for RF, to communicate, for silicon photonics, to do optical transmission of data so you can save energy and cut down on weight and the airframes and other platforms that are needed. And it's about all of the technology features that have to be enabled for successful end applications. And I view the USICA chips and recent focus is incredibly important, and one that needs to be data driven, meaning that we need to, as a nation, use data driven approaches to choose the right technologies to meet those mission platform needs. And by doing that, we can make sure that we maintain asymmetrical advantage, and also do so in a fashion that selects technologies that have dual uses that not only have defense applications, but also have applications in critical infrastructure. Think about 5G and 6G, right? And technology nodes that are the Goldilocks technologies for those RF communications, 45 nanometer, right? Making sure that that's done securely, done onshore, that we have a broad network within this nation for secure communication, right? It's about choosing those technologies and making them in a secure fashion to secure that critical infrastructure. Power grid, right? We're having a discussion before this panel started about susceptibility of the power grid across the nation, right? We need to leverage technologies to make that power grid more robust, and we can build those here, right? So all of these sectors, not only defense sectors, but the critical infrastructure sectors, can be positively influenced by these legislations and appropriations. I thank you, and look forward to discussions this morning.
All right, thank you very much, Ezra, for raising some issues that I'm sure we're going to dive into a little more deeply in our discussion. So moving the baton on to Mr. John Costello. Any opening remarks, John?
Certainly. First of all, thanks for inviting me to this. I'm kind of honored to be involved with this distinguished panel, and thank you for the introduction, and thank you for taking the time to attend this seminar. I could echo a lot of the things that my two previous colleagues have already mentioned. I've been in the industry about 40 years, 31 of those years at Microsemi/Microchip. We were acquired by Microchip roughly 3 years ago. We serve the automotive, communications, computing, industrial, consumer, and of course, mil-aero defense markets. And I've been in this industry long enough to see the transition from a DoD-driven market back in the 80s for electronic content to now a consumer-driven market with the dwindling supply chain when it comes to mission-critical components. So we do serve several markets with publicized global supply chain concerns, which was, I think, brought up by the pandemic, where they started looking at raw materials for pharmaceuticals and then realized, like, well, where else do we have these vulnerabilities? And it wasn't too long before they could connect the dots and realize that we're in the same situation with microelectronics. Now, from the aerospace and defense perspective, I think we're extremely vulnerable because if you look at every trade study or microelectronic trade study or industrial-based report, you'll see that it consistently comes to the same conclusions, that we are vulnerable and we are too dependent on foreign sources for manufacturing capability. Now, from the aerospace and defense perspective, it's much more nuanced and complex. It's, you know, there's tough compliance standards and regulations and that surround that marketplace, because these are parts that you don't put in handheld objects that are designed to either trade in or throw away after 12 to 18 months. These are parts that have to last 10, 20, 30 years, sometimes longer. We've been building mill standard diodes and transistors for 60 years, and they're still used across the board. So I think our main concern is, and we're very thrilled that the US government is focused on the semiconductor supply chain. We just want to make sure that they don't get too caught up in state of the art, as my previous colleague had mentioned, and not forget that, you know, the backbone of most DoD and space platforms are manufactured with mission critical microelectronics that are tested at the harsh environments that they're going to see through their lifetime. So that would be our main concern. But once again, nobody's against state of the art. We just want to make sure that that we don't, you know, our voices and our needs of this particular market space don't get lost in all the noise.
Okay, thank you very much, John. We'll move on to Robert McClellan from Micron.
Yeah, thank you, Mike. I'm very pleased to be here. I would like to say first that I think that Micron, where I'm employed, I would say we're a non-traditional contractor, if you will. We don't hold any contracts, so we're really excited about the fact that the government has been showing great interest in supporting our industry, I should say. We're also excited about the potential of public-private partnerships and seeing how all this plays out. And again, probably to iterate here what Ezra had said earlier, Micron, I could say in and of itself, is paying particular attention to those trailing nodes. If you look at what we're doing, particularly inside, say, the automobile industry, which transfers very nicely or dovetails very nicely into the DoD and the EIC. Thank you.
Good. Well, thanks, Bob, for those opening remarks. Appreciate that. So I'll just let people know who are on the line what our format is going to be. We're going to have about a half an hour of back and forth discussion with the panelists that I've prepared here, and then we'll transition to taking questions from the audience. So if I don't start with your questions, be patient, because I plan to get to most of them. Today. So we have sort of three phases: opening remarks, then a back and forth discussion with the moderator, myself, and then questions from the audience. So that's kind of how it goes. So let me start with phase two, the moderated questions. Several speakers already alluded to this, but I'd like to probe a little bit deeper, especially since not everyone had a chance to speak to this issue. And this is the question about, you know, state of the art. Why not? And let me just sort of put the devil's advocate question. Why not just SOTA? Why don't we just upgrade everything to state of the art, and then we don't have to worry about this legacy or state of the practice issue anymore? I know that's overly simplistic, but it's good to start with the devil's advocate question. Some of you have already weighed in on that, but would anyone else like to weigh in on why not just focus only on state of the art?
If you like, I'll start with that question. Well, you're right. It is somewhat simplistic, because when you look at the thousands of parts that are used on across the board, for instance, say a missile system. On a specific missile system, I won't mention the one, they use about 3,000 electronic parts. Those electronic parts may see radiation, they may see moisture, they may see vibration, they may see high temperature tests or extreme tests, they may see a coefficient of expansion that would cause parts to pop off the board. Point being is that if you try to redesign every mill system or space platform with a state-of-the-art part that you're not sure is going to hold up with form fit, not only form fit and function, but the environment it's going to see, there's not enough money in the budget to requalify every single device. And when it comes to, say, staple parts like transistors, diodes, capacitors, inductors, atomic clocks, what have you. You got to make sure whatever new design, the configuration will hold up under the conditions it's going to see, and there's no guarantee of that. And it's far too risky to use a state-of-the-art part that has not been tested or has proven technology or mature enough technology to have data to know that thing's going to work in a satellite, because the risk of failure for one of those systems can be loss of life if it's manned spaceflight, collateral damage of a missile for parts that catastrophically fail during the operation. So I think the risk factor involved with a state-of-the-art part that has not been proven through a series of mill testing or a process flow that would take it, that would remove the infant mortality from that part to make sure that it will work under the conditions it's going to see during its application. So that would be my answer to that question.
Thanks,
Yeah,
thanks, John. Anybody else want to weigh in?
Yeah, I would just pile on, particularly when you get to sub 10 nanometer, subatomic particles and the way they affect our bits, if you will, bits being lost, bits being corrupted. It's quite the challenge, and we actually find, those operating temps and things of that nature that are needed for the DoD, and to be able to hold on to those bits, the larger lithographies actually work better.
I'll answer
so Ezra,
with physics. So each of you probably have a smartphone on you, right? And a little switch that maybe put it in silent mode. Try wiring that up directly to turn on and off the lights in your office or your room, right? A little thing's going to fry, right? It's physics, right? You need to use the right technology for the right application, and it's not all about small nanometers. Those small transistors have absolutely a use, right, for CPUs and GPUs and applications that are heavily digital, heavily compute centric. But in many cases, that's not what you need, right? You need a full complement of technologies, and your smartphone has a full complement of technologies in it, right? Yeah, there's a CPU and GPU in there, but there's much more square millimeters of other silicon to do things like RF transmitters and receivers and audio codecs and everything else, right? And you need this full complement of technologies to build systems, right? And we have to use the right technologies to build those systems. And as you look at lithography, it's very easy to say, these small nodes are the leading edge. You can also use larger lithographies to do leading edge chips for other applications, leading edge RF transistors that are built on 180 nanometer technologies or 45 nanometer technologies. Wavelengths of light, right? You want to do silicon photonics. Well, you can't really cheat physics, right? So wavelengths of light that are used for optical communications, 900 nanometers and larger typically. Well, you need structures on the orders of microns to build optical devices that are integrated with digital devices to switch and control light. So it really comes down to, we need to understand the uses and optimize the technologies for those uses, and really shift the discussion from a lithography discussion to the features, right? The active and passive features and requirements these technologies use to achieve those end use requirements.
So Jim, any comments on this, Jim?
So my thoughts were similar to what Ezra has mentioned, as far as state of the art for high speed computing, those types of maybe game change or different types of capabilities, but that will be integrated with state of practice and different types of technologies to, as Ezra very, very adequately explained, in an iPhone or application. So the other thing I wanted to add to this is that state of the art, a lot of times there's tech nodes that they're chasing, and they have a chasing commercial business because that's what their economy, the economy of scale is based on. In state of practice, for government programs, typically they want the supply is a much longer supply. The development cycles are quite a bit longer. So state of the practice technologies are also a lot more stable, and they can be more stable. That's what this discussion is about.
So thanks, Jim, and I'm going to take some liberty as the moderator to get a slightly nerdy. I'll put my physicist hat on, right, and say, clearly, I think we, those of us in the field understand that the wear out physics, and all of us in this field understand, right? Wear out physics, chips age and wear out just like human beings do, just like we all are. And the wear out physics often is worse in bleeding edge because the fields are higher. And there's a bunch of mechanisms in there, because I worked this research area myself some years ago. So the wear out physics is something else that makes things perhaps less robust. So I just had to comment on that. But let me move to the next topic, since we have 4 representatives from industry specifically. Yes, some of them serve the defense market, but they all, I think, primarily serve the non-defense market. So one of the things I wanted to ask for when we're talking about state of the practice is, what are the non-defense drivers for state of the practice, and how, you know, is this important? Is this a growing area? Is this a shrinking area? Can people comment a bit on state of the practice as a business driver for their commercial business? So we'll start with Robert this time. I'm changing the order. So.
No, thanks, Mike. Micron, we're paying a lot of attention to big data. You've probably heard that hundreds of thousands of times, but the other driver there is going to be AI, ML, or deep learning, and in particular at the edge. That's quite a few applications to speak of, but most of it is in the surveillance and also in the automobile.
Good. All right. So John.
Well, I would echo some of the same things, but also understand that microchip, we're, you know, state of the practice and mission critical when it comes to military and defense is really our sweet spot. But in all those other markets, we don't necessarily have or are involved in the leading edge. But I do agree that when it comes to computing and you know, say artificial intelligence and machine learning, that's when I think your state of the art really comes into play. So again, since we don't play, that's not really our market segment or our technology focus. So I would probably defer to the other gentleman on that.
Okay, so Ezra, any comments on the commercial need for state of the practice, commercial drivers in the future?
Yeah, Mike. So Global Foundries is a proof point in the fact that there's explosive demand at lithography nodes 12 nanometer and larger across a wide range of markets. I mean, take compute. It's very costly to put functionality in, you know, 7, 5 nanometer technologies, right? So companies will look to, you know, split their chip architectures up and put what they have to at the most advanced litho node, and then, you know, put the rest at a larger node. You know, you look at RF. You know, 45 nanometers is state of the art for RF devices doing 5G and 6G communication, right? So there's a lot of legs left in lithography that's at, you know, quote unquote legacy nodes. And you look at all of the other pervasive applications from you know, Internet of Things to automotive to mil-aero, and you know, these technologies deliver you know, on over 70% of all the requirements. So it really, again, going back to my earlier point, that it's not all about lithography, right? There's a lot of other levers. You need passive components in chips, right, in the back end wiring to implement RF features. You need optical and electro-optical components for doing silicon photonics. There are a lot of features that can be enabled in these technology nodes that enable the end applications, right, to achieve the goal of the functionality, the energy efficiency, you know, the size, weight, and power requirements.
Thanks, thanks, Ezra. Jim.
And to add, yeah, certainly automotive industry, as we're aware from the chip shortage that's impacted them, has been in the news, you know, quite a bit lately. But you know, commercial space, these companies are interested in a viable solution. You know, when you look at a state-of-the-art solution with the lithography and the added complexity, the costs can be significant. So the commercial aero and space, banking and high security type of applications as well are very important to state of practice, and as well power grid and other in medical is another big driver. regarding the reliability you mentioned, Mike, and you have a implantable device and you want to have something that's going to be reliable and having a state of practice type of technology node with integrated into an application is very important.
Yeah, I asked the question for a reason, because clearly, I mean, we're sort of focused on defense needs, but you folks are deliberately commercial. So if there's a robust and long-term commercial market for state of the practice, and the government needs state of the practice, that's a good thing, that there's a commercial market, right?
That's the important part about our business model. You know, because the government volumes are, they're for defense systems can be one lot of wafers could be a life of program, procurement, depending on what the systems are. We have to have wafers running through our foundries every day to keep the lights on. And so that's a very important model for us to keep these facilities viable. And so supporting the commercial market is a big part of our business model.
Yep. No, I remember someone, it's probably out of date now, but someone saying some years ago that, a modern fab is at least $1 million a day. And correct me if I'm wrong, but it's probably more than that. You're probably burning more than that a day, right?
Yeah, there were a few quotes we shared. I'm not going to bring them up here. They might not be appropriate, but.
Yeah, I know. You don't want to put numbers behind things, but I can say, I heard it was at least $1 million a day. I can say that. I can't get in trouble for saying that. No attribution.
Just the way the quotes were, they were more old school and not something not appropriate for today.
Yeah. But what people need to keep in mind is fabs, in order to work, they have to be full. So, it takes a long time to build them. And we're talking about supply chain disruption now. It takes a long time to build them. But if they ain't full, they're not viable. Yep. So we got to remember that. This is part of supply chain. But let me, in fact, was someone going to say something?
Yeah, I was just going to say they're also very capital intensive, particularly up front.
Yep, absolutely. So let me move to a completely different topic on this, and I'm glad I have the representatives of the commercial world here. I was going to ask what people see, what our panelists see about any supply chain issues or challenges for state-of-the-art technologies. So it's a completely different kind of question, and so we'll start this time. With Ezra. So what's the supply chain situation? Especially, domestic and supply chain situation for state of the practice, Ezra.
Yeah, so for state of the practice, Mike, we define state of the practice maybe a little differently depending on which lever you're looking at, right? So from a lithography perspective, you could say state of the practice is, 16 nanometer and larger. If you look at it from a feature perspective, right, if you look at any given sector, state of practice, like I mentioned for RF or 5G and 6G might be, 65 nanometer or 45 nanometer. So I think it depends on which metric you're looking at. We have such explosive demand. Our worldwide fabs are completely full, right? And we're working urgently to expand capacity. For example, at Fab 8 in Malta, New York, we've secured a 66-acre land option right next door to the factory, so we can double the output in the coming years. That's the explosion of demand, and we're doing this through long-term partnerships with our customers and our own investments, and upcoming pending appropriations from the U.S. government to accomplish this. And we're not just expanding in the U.S., we're expanding in other geographies around the world, right? So in Singapore, you saw a recent announcement, and then also in Germany for our Dresden facility. Right, there's action within that region of the world as well on making sure this industry is robust. So the proof points are there that commercial industry is driving these pervasive technology demands, that companies are responding to that and increasing capacity. The challenges we see, right, tool procurement lead times are increasing, right, as everybody's looking to expand capacity, right, that's an issue. And people, talent, those are challenges. Right, you can't grow talent on trees. You can't train people in 3 years. Maybe a tool usually takes 12 months to procure. Maybe it's extending to 18 months. Right, that's a painful. But bringing people through years of education and years of industry experience to be skilled talent, right, that takes a much longer timeline or perspective. So we, as a nation, need to look at this very holistically to build up the full supply chain of technologies, IP, talent, and ability to access the tools that we need.
Good. Well, thanks, Ezra. Let me move on to Jim on that question. What do you think, Jim? What's the supply chain situation for state of the practice here in this country?
For state of practice in this country, as I mentioned in my introduction, I think that the availability of onshore facilities with different nodes and different technology applications, depending on RF or digital or analog, is I would say healthy in a sense. As far as the supply chain goes, though, some of the issues that Ezra mentioned, if we're going to be building 4 to 5 fabs here in the U.S. in the next 5 years, the supply of human people, of resources with the right STEM type of and other types of skill sets to support the foundries, as equipment lead times will be impacted as well. So those are the concerns that I have looking forward to with the state of practice supply chain in the near term.
Mm-hmm. Okay, thanks, thanks, Jim. So, John.
Yeah, on the state of the practice, well, I think obviously the pandemic kind of threw the demand cycle into a little bit of a frenzy, and I think that disruption is what exposed a lot of this. Now we maintain 4 onshore fabs, and we handle quite a few of our products cradle to grave. So we did get impacted. I think in terms of state of the practice, like Ezra, we define state of the practice slightly different for the markets we serve. Saying, mil-aero, we call it mission critical, and all other the markets we serve, we would probably describe them as state of the practice. So it's our particular business model seems to work very, very well, and I think even through the pandemic, they were able to thrive, except with the automotive situation, where when those orders got canceled, we didn't see the true demand cycle till much later, which caused a disruption. However, what we didn't anticipate, obviously, was all the people that used that time to upgrade all their at-home networks and all their commercial devices they use to either keep themselves busy or entertained when they're at home. So that really threw what was a more of a predictable cycle into a non-predictable cycle. But once again, our business model, we do quite a bit of our stuff onshore, and it's appealing to our customers that want traceability and a secure supply chain, because it only it doesn't, a lot of the stuff doesn't go offshore, so we're not worried about, say, counterfeit parts or parts that may have been compromised by a foreign adversary. But for the most part, Microchip has been able to weather the storm and at the same time thrive based on our other market segments.
All right. Well, thank you very much, John. So, Bob, the state of the practice and supply chain and domestic supply chain, what are your thoughts?
Yeah, I would just like to pile on to a couple of things the other panelists have said. One of the things that we found out when we were expanding our facility in Manassas was, yes, it could be a challenge to get the higher level skill sets into the facility when it's built, and maybe even the tooling, but that's not been, that hasn't proved a problem for us. What did prove a problem was the skill sets were not available for the trades, the trades, meaning the electricians, the plumbers, things like that, to build that high-tech building. We were, well, I can't go into the details, but just something else to be aware of. It's just not the high tech. It is also the trades into building these facilities. And then just in general, we do need to start building here. It follows, the logic follows. We do need to build here if we intend to keep the talent here. Right now, we are definitely seeing a lot of our educated talent moving overseas because the jobs are actually still moving overseas.
No, that's an excellent point on the STEM issue, right? Because you don't have activity and people will go where the market is, right? Where the market lures them. So you start losing capability. That takes a long time to get back. We all know what it takes to train a talented person in this field. These are a lot of skilled jobs, right? This is skilled labor we're talking about.
Well, the industry is getting smaller. You know, people like myself and these panelists, you know, you heard the joke 7 degrees from Kevin Bacon, but literally, you know, you run into people that you've worked with, and the supply of incoming, you know, college grads and others isn't making up for the losses we've had. To be brutally honest, I see that, and I'm sure that others do as well.
So I'd like to move into another topic area for this discussion, and that's we all know about Moore's law coming to sort of an asymptoting out. I think we all see the trend going on there. And so there's been a lot of thought about what's coming beyond Moore and what's the next big thing. From our perspective, at least at a think tank, we see a lot more happening with customization to function. Certainly, we understand the big systems companies are all getting design teams now. People who never designed their own chips, right, are having big efforts to design their own chips. So custom to function is a big deal. So I'd like to ask our commercial representatives here, what do you think about state of the practice in enabling new kinds of customization, or to put it another way, evolving business model to things that are much more toward the high mix, low volume, rather than the low mix, high volume, you know, paradigm that we've had for decades, you know, with Moore's law. As Moore's law comes to an end, we see a lot more customization. So my question is, what is the role of state of the practice technology in enabling customization and new kind of a business model going forward? So maybe this time we'll start with Jim on this.
Sure. So my first thought, you know, with this question, I start thinking about advanced packaging and the customization. You can do it more than more, having a multi-chip or system and package type of modules. And so state of practice technologies from the different application spaces, from RF, if there's an optical or secure computing type of needs, would remain the backbone of that, integrated into a swap C type module with you know, more advanced, maybe SOTA type of capabilities. If you need high speed computing, think of a hypersonics application, for example. So the model will shift, and you can use the state of practice type of capabilities, say in silicon interposer. Well, a state of practice back end of line, you know, type of CMOS node, if it's a highly integrated where you have a really significant level of with the complex parts on it, is a great integration technique if you need to have that for reliability, if you don't build it onto an organic substrate or that type of a thing. So there's a lot of applications for state of practice as we go into a more and more type of regime.
I'm actually fascinated about the evolving business models, right? Post-Moore.
Right.
I think there's going to be some big changes, and that's why I'm. So John, any thoughts on the evolving business models and customization and state of the practice?
Yeah, well, interestingly enough, because of the amount of acquisitions and divestments Microchip made over the years. Remember, I've only been a Microchip employee for 3 years. Most of my career is at Microsemi, where my focus was on the very low volume, high mix market space, which was mostly aerospace and defense. However, to answer your question, we had several facilities that we actually divested that were involved in using those state of the practice technologies and applying our reliability levels to different market space. Namely, we use some of our space level technology to modularize high reliability devices for the medical field for, as somebody already mentioned, in terms of implantable defibrillators and pacemakers, implantable insulin dispensers and things like that. So we were able to take some of that state of the practice and for, you know, for size, or, you know, size, weight, and power, able to modularize by die stacking and other methods of assembly in order to accommodate and use, say, state of the practice to come out with a customization product to serve another market space. And I would definitely point from our space level parts that had to be that reliable to, to market those products because of the reliability and the state of the practice reliability and the maturity of those products, to have the medical people trust those enough to use them for, implanting in the human body. Obviously, these things are designed to, you can't go up there and plug anything in. These are designed to work for a long time, because you don't want to be opening somebody's chest to change the battery every few years, right? So, so in doing that, I think that's the best way we've been able to apply state of the practice to come out with customization of parts for other market segments.
Thanks, John. So let me turn this over to Ezra for his comments on the evolving business models, customization, and state of the practice.
Great, thank you. So think of the smartphone again, right? So the insatiable demand from consumers, drives the business cycle to refresh these, and these are pushing 5G and 6G infrastructure, right? That's going to be built on 45 nanometers for the RF, low latency, high bandwidth connections, and then you're going to be looking at devices, whether it's smartphones, automobiles, or IoT, that connects on these low latency, high bandwidth channels, and then you have decisions as software is coded to, do I do things at the edge on this battery, powered constrained compute platform, or do I do it on the cloud because I have a low latency, high bandwidth connection? And what that's going to drive, I believe, will be the things that are in your edge will have to be optimized, right, for energy efficiency, for battery life, and that will be a co-optimized silicon and software design cycle to get to a very efficient architecture. And then that low latency, high bandwidth connection will allow for other compute to happen in a energy efficient cloud environment. And so the future, you could look at other industries, other applications. It is being fueled by these pervasive differentiated technologies that are predominantly in these state of the practice or even state of the legacy lithography nodes, right? Because those are feature-rich technologies that serve the requirements of the needs. And at the end of the day, let's not forget, this is about systems, right? It's about creating the things that consumers will use and that soldiers will use, et cetera. And those systems require a wide diversity of components.
So thanks, Ezra. To me personally, it's always, it may be for business, there's anxiety, but whenever there's a paradigm shift, it's an exciting time in terms of creativity and business smarts, right? It's always an exciting but disruptive time. So let me turn that to Bob. Any comments on the evolving business models, customization, and state of the practice?
Yeah, I would just add to, again, the panelists, again, that the distinction to go in last allows me to pile on, right? And historically, Micron hasn't necessarily done a lot of customization. However, we are making a great effort to climb up the value stack, if you will. But to do that, we're also depending on our partners. And with the government audience on board, not only supporting the big semis, if you support the small guys, the systems integrators, packaging assembly, you will be supporting us as well in the entire industry. This will lead to success for all of us, a win-win all the way around.
All right, so thanks, Bob. I think it's actually it's a very exciting time. Like I said, it's not boring at all when you're at a paradigm inflection point. So I might ask one or two more questions, but I see questions starting to come in on the chat box, so we're going to get to them. I just want to remind folks who are online and listening, please submit your questions in the Q&A section, because we will get to them, and we'll have a good discussion of your particular questions. But I'd like to move sort of the big elephant in the room that we talked about, the government investments that are being thought about in the USICA legislation, especially when it comes to large semiconductor investments. So what do people here think from their representatives of their industries, especially involved with state of the practice technologies? What should the role of the government be in this particular technology segment, right? Are we weak in certain areas where people would benefit from investment? What are their, if they were king of the day, if they were a government advisor, what would they advise the government to do in this particular area here? And this time I'll start with BMAC.
Wow, that's a tough one. And
If you were
trying
king
to-
of the day, BMAC.
yeah, being careful. I would say get us involved as early as possible, not be prescriptive and allow the experts that you do consult with to speak and to listen to what they're saying. They've been doing it. You can tell we've had decades of experience here just on this panel, and that's the kind of support you're going to get. I think that's my main thrust there.
Mm-hmm. All right, thanks, Bob. We'll move on. We'll move on to John. John, if you were king of the day and we're giving government advice on how to spend some of their investments,
If I was king of the
what
day,
would
I
you
probably
say?
wouldn't be involved in government at all. I'd probably be in the Cayman Islands. Anyway, I think bottom line is I'm thrilled that the government is looking at the semiconductor supply chain. And I think the important part here is lawmakers must recognize the difference between mission critical, state of the practice, and state of the art, because some of the really more vulnerable supply chains, say aerospace and defense, could get overlooked. And that's where people have exited the market over the decades. So once they understand that vulnerability, I think the private-public partnership strategically done, working with industry, and not just so intent on focusing on state of the art. If the investments are made wisely, and I'm not talking about a subsidy, I'm talking about a private-public partnership where they invest and we invest, they could sustain with a minimal investment, the supply chain for the real critical needs for a very small number. And that would guarantee the supply chain for the next 3 or 4 decades if done properly. Now, and that's on the aerospace and defense side. Now, on the commercial side, on what we've just seen in terms of the automotive, there are certain, and once again, we do a lot of onshore manufacturing, it is, but there's certain operations we can expand with government investment and bring certain operations that we do offshore and bring them onshore and be much more self-sufficient. So I think if they take a pragmatic view of it and spend money wisely and strategically, I think they could really shore up the semiconductor supply chain and make us far less dependent on any foreign sources. Now, obviously one of the concerns is how does the Department of Commerce, which is where this, I'm assuming this bill is still the USICA is still funding through Commerce. How does Commerce turn around and what is the mechanism for Commerce to address DoD and other needs that may be kind of out of their lane? So I think that might be a challenge going forward. But once again, I think if government is working with industry leaders and not just the state-of-the-art leaders, but other players in the critical supply chain, that they could actually do a great service to this country by shoring up our supply chain onshore. So that's what I would say.
I appreciate that, John. And there's still government positions available, right? If you want to jump into the government side.
I still like to be the king for the day thing.
Oh, okay, all right. Just saying. So, Jim, if you were king of the day.
Sure. And first, I'd just like to acknowledge that the problem is, the challenge, the opportunity, I'll call it, is very significant. My thoughts are, along the lines of the government response. I'd recommend a cohesive, engagement with the different government organizations that are involved and have stakeholders that are a primary interest to both the commercial, economic, but also defense, national security. So an engagement between DoD and different organizations, and make sure it's cohesive would be my first recommendation. Secondly, as was mentioned, the public-private partnership model. We have, and I'll steal this line from a colleague that's probably on the line here. We have brick and mortar here in the United States. We have facilities. We don't, we have zones where there are capabilities where you could expand on those capabilities with maybe additional add-ons, but also existing brick and mortar as opposed to starting from greenfield from bare. You know, that if you start from greenfield into bare effort, you're going to add another 3 years, you know, or more, depending on what the construction efforts are. Consider we talked about the STEM issues and if we're building fabs. So in order to have a more immediate impact, those would be the three, you know, my first three things: cohesive, public-private PPP, and you know, look where we have brick and mortar, look where we can optimize that, or you know, take advantage of that. Would be my recommendations.
Thanks, Jim. That offer stands, right, for people who want to serve in the government, right? Keep that in mind.
I was
your
a
next
contractor
adventure.
to DOE and NSA for 12 years. That's where I learned my mission focus. So I really
So you understand. Well, I was in the government a couple of years too when I was at DARPA, so I understand both sides. So it's important for having a foot in each world. So Ezra, if you were king of the day giving advice to the government, what would you say about the investments in microelectronics?
Yeah, so semiconductors, chips, it's the new oil, right? This is part and parcel of highest importance to economic security for this nation, right? And other regions of the world have recognized and taken action on this. Look at China with $100+ billion committed to this industry. South Korea, Taiwan, EU, IPCI, right? We need to level the playing field by getting the U.S. on that same cost of fabrication, cost of maintenance of facilities, so that businesses can make wise business decisions to place their expansion in their facilities in the U.S. Second, we must have leadership in the government that is technologically savvy, right? This is the most complicated industry on earth. We cannot have anything but data-driven decisions, right? We have to have a deep cognizance of the complexities. There are no simple answers. There are no silver bullets. This is a complex worldwide supply chain. We have to have not only skilled leadership leading that effort, but we have to have continuity over time for that leadership, right? And that group, that team, must take national security also into account as they look at economic security for the nation, to apply a very thoughtful approach to targeted investments, right? My colleagues made some excellent points that brownfield expansions is the quickest path to success here. You have companies already in the U.S. with footprints that can very quickly expand and very quickly implement or onshore technologies, right? That is the quickest path to moving the needle and must be first on the list. And these decisions cannot be done in a vacuum. To echo my colleagues' earlier points, that there must be deep collaboration with industry, right? Nobody can sit in an ivory tower and figure out the answers. This is going to take collaboration and a lot of dialogue to get to those data-driven decisions. And it's a very exciting time. It's also a time where it's an unprecedented amount of complexity, right? So we must get our arms around this. We must understand it. We must make those decisions.
So thanks, Ezra. And I do want to shift to the third phase of this meeting. And unless BMAC, you had a comment?
Yeah, just another thought. I guess I can't let go of the kingship. I'll fight John for it.
He's fighting Ezra for being king of the hill.
Just a thought too. Ezra made me think of this when he said the economics. The economics is also associated with the ease of doing business as well. And of late, there has been a deluge of requests for information, I'll call it, with threats as well too. Everything from CMMC to AFSC, this, that, and everything else. So the ease of doing business is going to be something to consider, something when you start talking about that public-private partnership. These are the types of discussions that should also be had.
Yeah, thank you for bringing that up. That's very important for everyone to give some thought to. Before moving to the next section, I did want to just say one or two remarks about the comments on public-private partnerships. We all know what they are around the world. I've been lucky enough to visit a lot of the consortia around the world in my career and see how people operate all over the world, in Asia and Europe and in the US. But the ones that work tend to have a clear role for both. I mean, they're a lot more than just free money, right? And I think we all agree there needs to be a real, here's the role of industry, here's the role of government. And you can't just be here's a bag of money and walk away, right? Those are the ones that have long-term legs. So I think there's a lot of potential in a properly structured public-private partnership, but only if there's clear roles. It has to be win. There has to be a win for both parties. The other thing I like to say is long-term sustainment on the government side is actually very important. It can ramp down with time, but there needs to be some fixed amount of money that doesn't go to zero in these things, because that's basically the IRAD. That's the IRAD that these places use to not become job shops. I'm sorry, I'm getting on my own soapbox.
So Mike, thank you for bringing that up. That's really important, because the long-term sustainment and viability, this isn't something that you have a shot in the arm and you walk away from. We have to have, and we've talked about this, amongst some of our colleagues, that we have to have a long-term outlook on this, and key integration of programs, and so that if we can't cancel one because of a change of administration or something like that. These are things that have a long-term effect, and so I'm glad you brought that point up. That's very important.
Yeah, if I may add, that is a good point. And what I think sometimes we have to realize is some of our adversaries, they can integrate easily their industrial, economic, and military policy, say China, for instance, but we have to deal with a change in administrations and people with different ideas. So that will help, that tends to disrupt our ability to align those policies to make it successful here in the US. So I think that is a great point, and it can't be forgotten.
Right. Thanks, John. I think there's just a lot of mileage in doing public-private partnerships right. So that was a great topic to talk about. So I'd like to move to the third phase of this, which is the questions and answers. And thank you, folks, for putting things in the chat box. I'll just remind everybody what the protocol is. I basically don't do attribution for this in order to stimulate open and frank discussion. So you will see your questions, but I won't attribute who made them unless the person who asked is particularly interested. So let me start with the first question that came from person X, or person Y, shall we say, right? Anyway, what's the state of the practice in business outside of the US, right? How is the state of the practice technology doing outside of the US? How competitive is the US with the rest of the world in state of the practice? And what needs to be done in this area to support the domestic activities? I know that's a very broad question, but would anyone like to weigh in on that?
Well, I can probably address it from the aerospace and defense, because that's one of our, aerospace and defense is one of our biggest exports. And I think it's, last time, I forgot the last number, but it was somewhere to the tune of trade surplus of about 90 billion or something like that. So I would say when it comes to, aircraft and, weapon systems and satellite systems, I think that, our state of the practice is in excellent shape when it comes to those industries, because we are one of the biggest exporters of them. As it pertains to some of the other market segments, I defer to the other gentlemen on the panel.
Yeah, so only because these questions address sometimes your particular expertise. So just chime in if you're particularly connected, but don't feel obligated to talk about every question. So anyone else want to remark on this? And if not, I'll move to the next one.
I would just add that you have to look at the state of the practice in different countries and regions through a filter. Think about how their government or their economies work compared to how we have state of practice here in the U.S. in our economy. So they're for what it is worth, or whether it's fair or not. There are different competing models. We're all aware of, and we brought up what our adversaries are spending on foundry or semiconductor technologies, China, for example. So keep that in mind. I mean, we are commercial entities and operate that way in our economy. Other state of practice suppliers in other countries or other regions are not in that model.
Yeah. Yep. Okay.
I will add very
Ezra?
briefly. Yeah, just very briefly that, there's a 30 to 50% penalty to, expanding in the U.S., compared to some other regions. That needs to be addressed. And, that can be done through incentives, and that can also be done through driving demand, right? So we need to look at this from a holistic business perspective, to make sure we're successful. And state of the practice, right, as we apply it to lithography, also means we need to do a better job of doing research and development in these lithography nodes and bridging that important work to production, right? There's no point in doing research and development if we never actually bring those technologies to production, and we need to prevent, IP leakage to going elsewhere, right? Let's make sure those investments go to the U.S.
Yeah, I've seen, Ezra, I think we've all seen that. I've seen studies that say one of the big differentiators with our overseas competition there is the incentive, right? It's not just cost of labor, but actually incentives that foreign governments are willing to do is a big factor that we need to address. So,
a couple of remarks on that too. When you speak of what's going on overseas, you can't ignore the geopolitics. We've had a conversation here, basically looking at the idea of low-cost geos. Are they really that low cost, particularly in terms of, as we've seen risk today in the pandemic, so forth and so on. The other thing that you mentioned was incentives. I would caution, maybe not the right word, but incentives that are sustainable, not something where there's a tax credit or something that's going to expire in 5 years or something like that.
okay, thanks, Bob. So let me move on so I can get through a couple of these excellent questions that people have submitted. So here's one from person Y. How are you investing in the education and the skill sets that the trade and the business needs? Lots of companies are not willing to invest in junior talent for the good future of the company. Lots of PhDs are unemployed or have low salary based on massive student loan debt they have. In fact, we discussed that topic at our first Futures event specifically because we had an academic involved in that. So does anyone want to talk about the STEM aspect here that this person asks?
I can tell you that Micron's very, very aggressive. And from a local perspective, I'm personally involved myself, even going down to the high school level and, giving tours of the plant and things like that to instill some kind of excitement for the STEM. But also, I believe the Manassas plant it's about 20%, maintained and operated by veterans as well. So we have some good opportunity to go into the military branches of service where there are skill sets that transfer very well, not only onto the factory floor, but also into the engineering department, R&D departments, test department, all that good stuff. So we've got a very, very aggressive outreach program here in Boise, out in California, in Texas, as well as here in Northern Virginia.
Anybody else want to weigh in on the STEM issue? We had a great discussion about that at our first event, by the way, but please, any other thoughts on the STEM challenge?
Sure. Yeah, Microchip does do a bit of outreach. And once again, I don't have all the details of it, but these are just things that I've read about in the newsletters. But we were involved in it when I was in Microsemi. We had outreach for STEM. I think we invested in specific science labs at universities like UC Irvine and Chapman. And I think there's some things going on in Arizona as well, because now that our corporate office is in Chandler, there's some outreach there. I'm not quite as familiar with them after the acquisition, but I know that at the time Microsemi did do outreach, and our concern would be the talent coming out of college to get them interested in, especially when we were focused on aerospace and defense, because all these engineers were going towards the the Googles and the Facebooks, and they weren't as intrigued as they were years ago in the space program and commercial aircraft. And I think some of the bigger companies, some of our primes have done some of the same thing. You can see some of the commercials in between sporting events about some of the prime contractors and showing some of their exciting projects. But I honestly think things like the Ingenuity and the Perseverance and the Rover, that can if they build on that, they could really generate as an industry more interest in students coming out and focusing on that market space.
Yeah, I'll agree, John. That was some of the most exciting TV I've seen. The Mars landing video was something that certainly will jazz up any potential techies.
Yeah, and if they could build on that, and interestingly enough, there's not a lot of state-of-the-art parts on those programs.
That's an excellent point. I just wanted to make one point too, John, that you mentioned Google and Facebook. We think of them as software companies, but guess what? Google and Facebook have serious design teams now, chip design teams.
Right.
So this is part of the changing industry, which I think is quite exciting personally.
Well, I know some of your colleagues from DARPA went over there, right?
Yeah, no, I know. I'm aware. Yes, absolutely. Good comment. So anything else on the STEM front? Because it is, I mean, we're all like all of us are a little bit older. So replacing ourselves is an important mission that we have. So what are we thinking about STEM?
I'd like to add, Skywater, I was engaged in outreach. We have co-op programs. Some of the best ways to get engaged in this industry. I know when I was a second-year student and looking to figure out what I wanted to do in an engineering program, landing my first co-op job in a semiconductor business pretty much solidified that back in the end of the 80s. I know that there's a lot of demand for STEM graduates, speaking to colleagues and other prime companies that have, thousands of positions open, foundries. I look at the Skywater job site if you're looking for a job.
There you go. There's a clear answer right there, right?
But, I'm running into, I've been here for 7 weeks, and I'm running into RIT alumni that are co-ops, and it's great to see. So some of the avenues are out there, but that needs to be magnified again, like it was maybe back in the day when I was in school. In my opinion, I'm not sure how to do that, but the infrastructure is there and the demand is there. If there's people that with the right degrees and the right backgrounds and pedigrees that are looking for a job right now, would be disappointed to hear that.
Yeah. So any other thoughts on STEM, or can I move to the next topic, folks?
Just one brief comment. So, the facility I work at, Fab 9, I've been there since 1995. It's in Vermont, and we're the premier supplier of most of the RF chips and all these smartphones. Pretty amazing, and it's been a result of innovation, right? So it's 90 nanometer and larger technologies on 200 millimeter wafers. And it's through innovation that site has really excelled to be a leading site in our company for business metrics. And sort of recognizing this talent pipeline challenge, we've partnered with local University of Vermont, for example, where we're having professionals from our company donate their time to teach full-time courses to build that pipeline of talent, right? And I've done many visits to elementary schools to spark that interest at a young age, and in engineering and science. I think we as companies and individuals have that responsibility, right, for this nation, for this industry. And I think our country needs to step it up as well, right? We need to, do another moonshot type of thing here for the U.S. and really just step up the game to compete on the worldwide stage. I mean, the world is now flat, right, with the enablement of the internet from all these chips, right? And so talent around the world can contribute on projects. I think this pandemic has taught us that working remotely does work. And so we have truly a flat world, and we need to compete.
Great, thanks. A very important topic we could spend the rest of the half hour talking about, but we have a few more questions I'd like to get to. So the next question from the audience is, the market is driven by system companies and not by the semi makers. They are the ones that should voice their needs, and the semi community should work on how to provide possible solutions for these systems companies. Without this connection, any strategy is disconnected from reality. The PC made the success of Intel, the iPhone made the success of Apple, and the technology evolved accordingly. The next discussion should be with the system companies and listen to what they need. What does the panel think about the importance of the system companies in driving the semiconductor market going forward? That's a complex question, but clearly someone with business acumen asked this one.
I think this is a spectacular question, right? And it's what I've been talking about with getting to data-driven decisions. My company, Global Foundries, we used to be technology focused. We have all these technologists, and you'd be looking at that technology sector and trying to make it better, and thinking then the business will come. We've completely restructured our company to be customer and use oriented, right? We have 3 strategic business units to look at what do the customers need, what are the application requirements to then deliver the right technologies, regardless of what fab it's from or which technology lithography node it's from. And those system requirements should be driving all of these decisions, right? The data-driven decisions. What do these systems need, both for the commercial and the defense markets? That's a fabulous question.
Thanks, Ezra. Anybody else want to talk about this this business question here? It's a great.
I think that was more of I think it was more of a statement than a question. But I mean, obviously, it was a good lesson in economics 101 in what's known as demand creation, right?
Yeah.
Build a better mousetrap. So I mean, that's kind of what it says in a nutshell.
Yep.
Yeah, I would just add to that. I am systems focused. That is my background. Don't exclude the end user. I think they're a very important part of that discussion, not just the systems companies and then the semis, throwing parts over the fence, if you will, like of old. But, folks like me are now getting out and getting into discussions with end users and understanding requirements from the people who are actually operating the systems.
I mean, my comment on this, I'll take sort of a moderator's prerogative in commenting on this, is it's amazing to me that all these big systems companies who historically bought parts, right, from suppliers, now have their own design teams, because that's the way to differentiate themselves in the market. And that's a fascinating trend, right, that bodes entirely new business models going forward. We never imagined that these companies would all have their own design teams, right, but they do.
Right. And so also in my, part of my job is to be working with these systems companies. And, part of my travel, I was in the East Coast yesterday is meeting with our customer base and finding out, as Ezra mentioned, what their requirements are, what they need, and mapping what our solutions are from a device or technology node perspective to that and what the future brings. The other thing I'd like to add, though, in systems companies, some are vertically integrated, some are not. So, Mike mentioned they have design teams. I've worked with some systems companies that have a design team, but the rest of the work is through subcontract to maybe a prime or something like that. And there's others that we're very familiar with that are extremely vertically integrated. So there's different approaches in the systems primes community too. Just so keep that in mind.
Thanks for those comments. I'd like to move on to the next question here. As we enter more and beyond CMOS paradigms and desire onshore fabrication capabilities, one can imagine novel fabrication technologies to enable desired functionality and potentially reduce capital costs. Interesting, yes. From an industry perspective, what capability demonstrations in the future, right, would be the most compelling of these new technologies, and are they application specific? So this is sort of almost a post-Moore question. So anyone would like to weigh in on more or beyond CMOS, novel fabrication technologies? What's coming down the pike, right? Or is it all customization and advanced packaging, or are there other technologies that we should be cognizant of?
Well, we're aware of efforts like 3D SoC that we're working with here at Skywater is a potential different approach. Carbon nanotube, everybody's aware of maybe niobium-based quantum computing type of technologies. Those are some of the things that come to mind quickly. There's others out there that I'm sure my colleagues here will bring up. The other, more, again, I'm going to mention this advanced packaging. We had that 100-day report that came out, and I think advanced packaging may have been mentioned a few times, but advanced packaging onshore, again, enables this integration, depending on what your substrate and how that all works, but it enables this integration of these novel techniques or state-of-the-art type of technologies where you need high-speed computing to our state of practice backbone. So I just wanted to bring that up, and advanced packaging is a very important thing, onshore advanced packaging.
Good, thanks, Jim. Any other exciting new technologies coming down the pike that we should be aware of here, folks? Well, I'll mention one just from because partly from my own exposure to it in my own career, and that's more of the custom patterning, right? We're all going more to custom solutions. So I know there's been we all know there's been decades of work on non-optical on various kinds of e-beam and sort of single wafer processing capabilities. Does anybody think that those are going to make some headway into the commercial world? Because there's been lots of activities from different companies along those sort of multi e-beam kind of approaches. Is that something that people think has some legs in the future? No opinions.
I guess I'll comment that, from a high volume manufacturing perspective, right, we need to have business models that close. And so maybe these multi-pattern e-beam technologies could have some customization applications, integrated into a more traditional process. At the end of the day, you need to be able to turn out lots of units to learn and maintain yields, and need to do so in an economically viable way to close business cases. So I think there could be a niche there. I don't know that you could, and I'm not seeing a path to replacing an entire technology application with using that approach versus traditional lithography. I think it's more of a complementary type of approach that could win out.
Yeah. Following up on Ezra's comments, I agree with the niche. Depending on ConOp and level of security and that type of I'm not just gonna mention that where direct patterning techniques would be very complementary to producing certain hardware for missions. Again, I'm just kind of dancing around some things, but just those and capabilities will be important. And I know that we're working on those types of things here in the future as well for certain customer sets.
Good. Well, I've learned never to say never, because most of my career EUV was under development and it's actually deployed now. So I've learned never to say never, right? If people are really interested in a technology and willing to invest over the long term, it's amazing what clever engineers can achieve. So the next question is about digging a little deeper into the STEM question. So I think this is a follow-up on our STEM discussion. Very happy to hear that the companies are working to engage with young people to get them excited about this industry. However, part of the problem that we have heard about at the last workshop was the student debt burden. We all know about that, right? That's leading to people choosing different career paths. Are companies willing to help support students via scholarships? So what are people's thoughts about like financial incentives for students in the tech STEM?
Well, I think most companies, and I believe Microchip does have some kind of a tuition reimbursement program, but I'm sorry, I really don't know the details of it, but I know we are concerned about that type of thing in order to attract talent that are for bright, promising kids with that type of mindset for STEM that don't have the financial resources in order to attain a degree. So again, I believe we do have some type of program for that. I just don't have the details of it.
Anybody else want to weigh in on their company's attitude about scholarships and supporting financial support for STEM students?
Obviously GlobalFoundries takes similar, industry competitive actions and, promoting and fostering, new talent coming in. I think the question is a broader question than just this industry, right? So this nation, right, the cost of education is a huge problem and needs to be addressed at a national level, right? The companies are not going to solve this, right? We'll continue doing what we can that makes reasonable sense for each company. But there's just some larger action needed to, truly, I think, step up the game.
Okay, and I do know there's been consortia. In fact, they still exist now. And in my day, it was called the FCRP Marco Center, right? There are public-private consortia where the government and industry co-invested in supporting research and basically supporting graduate student stipends, right, for years in this field. And that's something that still goes on. And in fact, the main outcome of that for the interested investors wasn't necessarily the research. It was the degrees and the interest in the industry. So that's an example of a public-private collaboration that generates students that people can hire.
It is, but I think it has to be done strategically, because I know a lot of these I know, and I'm not going to mention any names, but I know administrators at some of these universities that they just take the opportunity, knowing there's a government subsidy, to increase the cost of tuition. So
Yeah.
I think you have to be very strategic in how you do that and make sure this isn't just a game they're playing to attain more money.
Yep. All right, I'd like to move to the no, it was let's see, yeah, that was my light. I'd like to move to another topic, and this one is a business topic for those people who are in the financial part of the business. So it's kind of a cool question. So with respect to the topics of subsidies to industry to maintain or grow the CONUS supplier base, wouldn't it be appropriate for the U.S. government to consider a value-added tax? So here's the VAT issue: a value-added tax on key areas such as semiconductors, especially since China and the EU currently have a 16 and a 15% overall VAT. Wouldn't targeted value-added taxes in the US support the industry in the long term and be better than tax offsets by local cities and states? So here's the VAT issue. I'm sure we've all thought a little bit about that, right? Because I have European relatives and I know about the VAT, right?
Hey, I remember, going to get the VAT tax I paid in Italy back reimbursed. So since I wasn't a citizen, but I think taxes in general is a touchy subject. If you want to remove some of the other taxes they impose, like out here in Southern California, which is one of the highest tax states, I think, in the entire country. I'm kind of the impression I'd rather have a national sales tax, remove all their taxes, because I think that would generate enough income when you bring in the underground economy, and it would do wonders for the U.S. Treasury. But in terms of a VAT tax, I think that's a tough sell.
I think very simply, let's look at what we're trying to motivate as a nation. We're trying to motivate onshoring of more of this industry, growing the U.S. share of supply of semiconductors, and we need to be very careful about what we do to make sure we're driving that behavior, right? So adding a value-added tax, that's going to add some barriers to implementing more of the supply chain in the U.S.
Interesting. Well, we're not going to solve this issue, but so Jim, you wanted to say something?
I was just going to say I'm not an economist, but
but you play one on Zoom, right?
I would just, as an engineer, my opinion would be to keep it simple and less complex. What that may be, I can't say, but when you have layers when you layer on a fix onto a layer, that seems to be a problem. That's all I'm going to say.
But also you got to realize, I think, that in certain market spaces, there's already tremendous compliance and TORs and FARs, and now you got new CMMC. And you're piling all that cost onto the product, and especially on the aerospace and defense end, where it's already a low volume, high mix proposition. That makes your price per part go way up. So, so I don't think that's the answer. And once again, I think that would scare investment.
Yeah.
Good comments. Yeah. Good comments. So listen. We have a little bit of time left, and I just want to keep that open. I've gotten through most of the questions here from the audience, but I want to give people a chance to make any final comments, because we have a few minutes left here in the session. So do folks have final comments? Do you want to throw some rocks at CMMC, or is there anything else that's on your mind that you want to talk about? I think that would be.
I'm not going to throw rocks at CMMC. I know those people. They're very fine people.
Okay,
got
good.
A tough
good.
Job.
I can quote you on that, John. Right?
Yeah, you can quote me on that.
Okay, good.
Well, so this is kind of a closing statement thing.
Yeah. Yep.
All right. Well, I guess I just believe that I think it's a great opportunity right now for industry and government to align with common goals to address economic security and national security at the same time. Once again, my biggest concern would be that the USICA, and since this bill started like $5 billion in authorization, and then now as it's evolved through several iterations, they're talking about $250 billion with $52 billion in emergencies funding, that they do address this very strategically and understand the difference between mission critical and state of the art. I think that's imperative. I think a lot of good can be done, but once again, the money has to be spent wisely.
Thanks, John. Any closing comments from our other panelists?
I would just make it simple again. I think Ezra called it. Follow the data.
I like simple. I like simple and direct, BMAC. That's excellent.
What I mentioned before, a collaborative type of an engagement with data, as Robert and Ezra mentioned, the data-driven decisions. We have a DIB here. We're all sitting here in this panel, and there's more that aren't here that are focused on mission of national security and being a viable, successful company generating commercial revenues as well. So let's figure out how to leverage that the right way, fix the things that need to get fixed right away, so that we maintain and then build on that to grow our economy and protect our next generations with maintaining our technological superiority for our nation.
Yeah, the way we grew up, Jim, when we were like completely dominant on Earth. So Ezra, any closing comments?
Yeah, thanks, Mike, and to all the panelists. Right? Just a fabulous discussion today. I think I'd add to our dialogue today with the U.S. government needs to be very careful as it makes those data-driven decisions and puts the money forth to industry to incent what these end goals are that Congress has mandated, and must ensure that there not be excessive strings attached to this funding. Right? If there's too many strings attached, then the risk will be, well, some of the issues that have arisen in the past. Look at the CARES Act loans, right? Why weren't all of those used? Well, too many strings attached, right? So the terms and conditions, the requirements upon industry that's going to participate in, helping this nation grow its share, must be palatable, must close with industry, and it's going to require dialogue. And that piece of it is probably the most worrisome piece to me, right? That this be done in a way that's going to be acceptable to industry.
So, well, thank you very much, Ezra. I first want to take the opportunity to thank our four distinguished panelists. I know we're all very busy and there's lots of stuff going on in our day, so thank you for carving out time to talk about this important topic. From the moderator's perspective, I certainly learned stuff here and was very stimulated by this conversation. I just want to re-emphasize that in my whole career, and I've been doing this for many decades now, this is one of the most serious supply chain investments in semis that the government has ever contemplated, and that includes Semitech, which, by the way, I worked on a number of Semitech projects over the years. So it's important, I think we all agreed to do this right. This is like a unique opportunity that comes along like once in a career, right? So we need to all provide good advice, and we need to get this right so that we have long-lasting positive effects from this investment, which doesn't come around. It doesn't come around every year, as we all know. So with that, I'd like to thank everybody for participating today online and in our panel, and I wish you a very good rest of the week. So thank you very much, folks.
Thank you, Mike. Thank fellow panelists, Robert, Ezra, Jim.
All right, take care, everybody.
Yes.
And thanks again. Bye-bye now.
Thank you.